This is a question about dehydration of alcohol. X is an alcohol which undergoes dehydration with concentrated phosphoric acid to produce only two organic products. We have to consider structural and stereoisomerism in this question. We are given four compounds A, B, C, and D. So we'll find out which one could be X. Molecule A, there is one hydroxyl functional group. Molecule A is symmetrical. The carbon with the functional group has two neighbors. Both these neighbors are attached to two hydrogen atoms. Dehydration of molecule A will remove the hydroxy functional group and any of these hydrogen atoms. Since the molecule is symmetrical, removing any of these hydrogen atom will produce the same alkene. So only one alkene is produced. Which is pent2-ene. But each carbon in pent2-ene sharing the double bond is bonded to two different groups of atoms. So this product has cis-trans isomer. Stereoisomerism should be taken into account. So two products are formed from the dehydration of molecule A. Now we'll look at dehydration of molecule in B. One hydroxy group. Both the neighbors have hydrogen atoms attached to them. Molecule B is not symmetrical, so that means more than one type of alkene will be produced. Removing hydroxy group and one hydrogen from the carbon on the left will give us this alkene. This alkene, two carbons sharing the double bond, are bonded to two different groups of atoms. So two different products because cis and trans isomers should be taken into account. The other alkene will be produced from removing hydroxy functional group and also one H from the carbon on the right hand side. So pent1-ene is produced. Pent1-ene, one of the carbons sharing the double bond, is bonded to two hydrogen atoms. So this pent1-ene molecule doesn't show any stereoisomerism. So this is the third product. Next, we'll look at dehydration of molecule in C. This carbon bonded to the OH functional group has three neighbors with hydrogen atoms. Molecule C is also symmetrical. So removing hydrogen atoms from the carbon on the left or on the right will produce the same type of alkene, which is pent2-ene. So we have seen pent2-ene as products in dehydration of molecule A and also molecule B. It has cis isomer and trans isomer. So two products are formed from removing hydroxy group and also hydrogen atoms from the left or the right carbon. Now let's look at what will be produced if the hydrogen atom is removed from the carbon below the functional group. Another alkene is produced. This carbon here is bonded to two hydrogens, so it doesn't show any stereoisomerism. This is the third product. Lastly, the molecule in D. Molecule D contains two hydroxy functional groups. Let me show all the hydrogen atoms bonded to their neighbors. Dehydration of molecule D will produce more alkenes. Let's start with the hydroxy functional group on the left. Remove this OH functional group and one hydrogen atom on the neighbor on the left. Removing only one hydroxy functional group will give us the first product. Removing the second hydroxy group only will produce the second product. And the second product shows stereoisomerism. So the trans isomer will be the third product. If both hydroxy functional groups are removed, we will get a diene. Fourth product, and this fourth product is cis trans isomerism. Now I've written down all the products that can be formed from dehydration of all these alcohol molecules. Molecule A produces only two organic products. So the answer to this question is A.